Okay, today we're going to use similar triangles to find slopes of lines. You'll notice that I have given you your slope formula right here, and you can copy and paste it to each one if you want to. So let's start off by finding points to find these lines. So this first one, I have the point 0, 0, and I have the point 4, 2. So my points are 0, 0, and 4, 2. So remember, it's y minus y. So y is always the second value. So it's going to be 2 minus 0 divided by 4 minus 0. So that gives me 2 over 4, which is 1/2. Okay, so there you go. Now, what if I get a different triangle? What if instead I use the points 4, 2, and 6, 3? Okay, I'm going to do this work in blue so you can tell where it is. So if I start out with the points, with the points 4, 2, and 6, 3 from this triangle right here, then I'm going to do 3 minus 2 over 6 minus 4. Well, 3 minus 2 is 1. 6 minus 4 is 2. I get that same slope of 1/2. Let's try another one. Here, you can see my two different triangles. So in red, I have this triangle right here. And that one uses the points 0, 9, and 2, 6. So I have 6 minus 9 over 2 minus 0. 6 minus 9 is negative 3 over 2. So negative 3 over 2 doesn't reduce. That's fine. And then here is my second triangle. It uses the points 2, 6, and 6, 0. So, again, I'm going to do 0 minus 6 over 6 minus 2. 0 minus 6 is negative 6 over 6 minus 2 is 4. And that reduces to negative 3 over 2. Okay, I'm starting to see a pattern here. I'm getting that same answer. Let's try one more like this. I want you to try this one on your own. Go ahead and pause the video and try this one on your own on your paper. Again, here's our triangles. So for the first one, we have the points 9, 7, and 6, 5. And then for our second triangle, which is right down here, I have the points 0, 1, and again 6, 5. So go ahead and pause the video and try those on your own. Okay, so as you can see, we should have gotten 2/3 either way when you reduce it. So you see that you get the same answer. So let's come down to our next page. So Carla plotted the points on the graph below to show how the amount she owes for tuition decreases as the number of tuition payments increases. So part A asks, what does the slope of the line segment represent? Okay, so that one we're going to go through very quickly. So, what does the slope represent? Is it each payment decreases the amount owed by $4,000? Each payment decreases the amount owed by 66 cents. For every 3 payments, the amount owed decreases by $2,000. Or for every 2 payments, the amount owed decreases by $3,000. So let's look at this. The amount owed is showed in thousands of dollars. Here I see she started off owing $4,000. And these are the number of payments she makes. So after 6 payments, she's paid it all off. So I can tell that it's definitely each payment does not decrease the amount of $4,000. That would pay it off in one. Definitely not paying it off 66 cents at a time. So is it every 3 payments the amount is decreased by $2,000, or every 2 payments the amount is decreased by $3,000? So after 2 payments, She still owes almost $3,000. After 3 payments, she owes $2,000. So that means that C is our answer. After 3 payments, the amount owed decreases by $2,000. Then they ask us for part B. They're asking us to write an equation for the line in the form of y equals mx plus b. So remember, we're only going to be replacing m and b. So b is our y-intercept. If we look up here, our y-intercept is 4. So b is 4. Or we can say 4,000. If we're doing the line, we can do it 4. So now we need to figure out the slope, because remember, m is our slope. So we said, if we use our triangles, we can use this triangle here. And I have the points 0, 4, and 3, 2. So again, we're going to do 2 minus 4, our slope formula, divided by 3 minus 0. 2 minus 4 is negative 2 over 3. So that's our slope. That's our m. So we're going to make this equation as y equals negative 2 over 3 m. Oh, no, not m, sorry. X plus 4, which is our b. Not too bad. Okay, one more problem, and then I'll let you guys go to work on your own. So, 2 triangles are created by the points shown below. Explain how you know that the triangles are similar. So remember, we've talked about similar triangles can be used to find the slope. We know that this, for each one of these, this is a 90-degree angle. This is a 90-degree angle here. Okay, so if you remember, when we have, so these are 90-degree angles here, and we know that they're along this same line. That means that this angle and this angle are the same, and this angle and this angle are the same. That means they have the same angles. Any triangles that have all 3 the same angles are similar. So that's what we can say is the triangles exist along the same line, along the same line. Okay, so just say, knowing that means that they must be similar, and their sides are proportional. And their sides are proportional. Because if we use them, proportional, I can spell, proportional. Remember, if we did this, we'd say, okay, so this side here, I can see this starts at 3, it ends at 6, so this is 3. This one ends at 3, and starts at negative 3, so it is 6 long. And then if we look at these horizontal, this one goes from negative 2 to 2, so it's 4. This one goes from negative 4 to 2, so it is 2. So it's proportional. You see that the small triangle, to the big triangle, we're doubling it. Okay? So use each of the triangles to determine the slope of the graph line. Why is the slope the same regardless of which pair you choose? Okay, so remember these triangles, we use it. So if we use the small triangle, we get, change in y, which is 3 over change in x, 2. The large triangle, we get 6 over 4, which is 3 over 2. Why is the slope the same regardless of which pair of points you choose? Slope's the same because it is one line. So it's one line with a constant slope, with a constant rate of change. That's what makes it a line, remember? Okay, so because it has a constant rate of change, it doesn't matter where you check, you will always get the same slope. Okay, so go ahead and work on your own. If you have any questions, I'll see you in class.